I'm going to show you how to find something called the greatest common factor, which we abbreviate as GCF, greatest common factor, as well as something that we're going to be focusing on next class, which is least common multiple, LCM, least common multiple. Now you will notice that both of these have the word common in it. And what common means in this sense is shared, right? We are looking for certain things that are shared between multiple numbers, okay? So that's what the word common means. Greatest in math means biggest. So we're looking for the biggest shared factor. Least or lowest in math means smallest. So we're looking for the smallest shared multiple, right? And so today I'm going to show you how to find the biggest shared factor. Factors are numbers that go into other numbers, as well as showing you how to find the smallest common multiple. And multiples are numbers that we get through multiplication. Like for example, the multiples of 5 are 10 and 15 and 20. And so what we're looking for is we're looking for shared numbers, either factors or multiples, between a group of data, okay? I'm going to show it to you all today because they are so closely related that if I did 2 videos, you're gonna probably think, am I watching the same video twice? And so I figured let's just do them both together, okay? The better we are at prime factorization, the better we're going to be at GCF and LCM. And so let's start by looking at prime factorization of these 2 numbers. And what you'll notice is on the left, I'm going to be using, if you remember correctly, I'm going to be using the chainsaw method over here. So on the left, this is going to be the chainsaw method, where I take a number and I chop it down as quickly as possible to make smaller numbers. 35 times 10 is 350. Over here on the right, I'm going to be using the butter knife method, where we are chopping down the number slowly, kind of using very, very small prime numbers. Regardless of which way that I choose to do it, you'll notice that slowly we get to a point where every single outside number is circled, meaning every single outside number is a prime number. The answer to the 351 would be this, 2 times 5 squared times 7. The answer to the 451 would be this one, 2 times 3 squared times 5 squared. Hopefully, everything that you're seeing right now is a little bit of a review from the last video that I made. In order to find GCF and LCM, we are going to use these 2 answers. So let me show you how that looks. Now, the first thing I'm going to do is I'm actually going to get rid of all this other stuff like the writing and everything because, I need the space. So I'm just going to get rid of this stuff, okay? But that stuff is important, Let's go ahead. We'll put the answers there for now. In order to find GCF or LCM, what we are going to do is we are going to take our time and make sure that we write the answers on top of each other using a very, very organized system. And so what you're going to see me do here is you're going to see me draw some columns. Now these columns, I would never actually draw these columns on my homework, but I'm going to draw them out for you right now so that you can see kind of my thought process, okay? This first column, again, which would be like an invisible column kind of in my mind, this first column is going to be for, all the 2s that belong in the answer. The second column in my mind is where all the 3s will go. This next column will be where the 5s will go and the 7s will go and so on. And so watch how I write the answer. We're going to put the 2 in the 2 column. We're going to put the 3 squared underneath the 3 column. And we're going to put the 5 squared in the 5 column. Now again, I wouldn't actually have these columns drawn, but they kind of exist in my mind for how I write the answers. Let's go ahead and write the red answer now. The 2 would go in the 2's column. The 5 squared would go in the 5 column. And the 7 would kind of poke out here in the 7 column. Notice that this spot is blank. And the reason it's blank is there's no 3 in this answer. To find the GCF and the LCM, what we are going to do is we are going to take some of these numbers, okay? So pay attention here because this is where it's important. For GCF, greatest common factor, we are going to look only at the numbers that they share. So let's think about it. Did both of my answers have 2s? Well, yeah, they did. Did both of my answers have 3s? No. Did both of my answers have 5s? Yeah. And then finally, did both of my answers have 7s? No. Do you see how we only have shared numbers in the 2 and the 5 column? For GCF, we're going to take the smallest copy of only what is shared. So let's take the smaller of these 2s. Well, these 2s are exactly the same size. They're just 2s. So I'll just circle this one. We're going to ignore the 3s because they didn't all have 3s. Let's take the smallest copy of these 5s. And again, they're exactly the same size. They're both 5 squared. So I'll just, I'll circle this copy. The GCF is going to be the smallest copies of what is shared multiplied together. 5 squared is going to be 25. 2 times 25 is going to be 50. The biggest number that went into our original numbers, and I erased them, so they're gone. The biggest number that went into our original numbers is going to be 50. The greatest common factor that they have together is 50. The way that we find the greatest common factor is we take the smallest copy of only what is shared. So now let's switch gears. Let's talk about the least common multiple. For GCF, we only cared about whether they were being shared or not, so the 2s and the 5s. For LCM, we don't actually care if they're shared at all. We just want to know, are there 2s? Yep. Are there 3s? Yep. Are there 5s? Are there 7s? For the LCM, we don't care if it's shared. We just want to know, does the number exist? And then the opposite of GCF, we don't want to take the smallest copy. We want to take the biggest copy. Let's take the biggest 2. Let's take the biggest 3. Let's take the biggest 5. Let's take the biggest 7. The LCM is going to be the multiplication of the biggest numbers. And guess what that means? That means we're going to get a pretty darn big number as our answer. Now I'm going to cheat here. I got a calculator sitting next to me. So I'm just going to go ahead and type this in using my calculator. And I get this big number, 3150. And what that means is the smallest number that my original numbers can multiply to become is 3,150. Now, I know I erased the original numbers, but I do remember what they are. This number in blue started off as 450. This number in red started off as 350. So let's think about our answers. The biggest number that can go into both 450 and 350 is 50. That's the GCF. 50 can go into 450, 50 can go into 350. The smallest multiple of these that both of these can turn into is 3,150. And again, 450 times 2 is 900. 450 times 3 is 1,350. 450 times 4 is 1,800. Well, eventually, 450 can turn into this number. 350 can turn into this number. Multiples. GCF and LCM. Let me kind of peek ahead. Let's take a look at a couple of notes really quickly, okay? We'll jump here. Greatest common factor. Well, what do we do to have to find the greatest common factor? Well, the first thing we do is we prime factorize. And then we ask ourselves a question. What numbers are shared amongst all of the prime factorizations? Then we multiply the smallest version of only the shared numbers. Compare that with least common multiple. We start off the same. We prime factorize. That's why we usually do both of these things on the exact same problem. Instead of saying, hey, what numbers do they all share? We want to ask ourselves, what numbers exist? Are there 2s, 3s, 5s, 7s, 11s, all of that stuff? And instead of multiplying the smallest version, we multiply the largest version of each number. Let's look at another example. Okay, so let's jump forward. We'll do 2 more examples, okay? Let's start here. Okay. Let's find the GCF and the LCM of these 3 numbers. Well, the first thing I'm going to do is I'm going to prime factorize these 3 numbers. Fortunately, these numbers are quite small, so prime factorizing them will be pretty easy. Finally, let's get to 22. The second thing I do is I want to write the answers to this prime factorization on top of each other using a really nice kind of organized method. I'm going to start over here with this black one. 3 times 5 is the answer to the black one. Now I know if there are any more 3s, they're going to appear under the 3. If there's any more 5s, it's going to appear under the 5. Let's go ahead and take a look at the red one. We're going to have 2 to the 4th. And the green one is going to have 2 times 11. Notice I don't put the 11 under the 5. I don't put the 11 under the 3. Now for GCF, let's ask ourselves a question. Do all 3 of these numbers, remember I got 3 numbers, I got the red, the black, the red, the green. Do all 3 of these numbers have 2s? No. Do all 3 of these numbers have 3s? No. Do all 3 of these numbers have 5s? No. Do all 3 of these numbers have 11s? No. In this particular problem, they do not share any of these prime numbers. And this actually happens relatively frequently. In this instance, the greatest common factor is 1. The 1 is always a factor to every number. When nothing is shared, I can't take any 2s because they don't share 2s. I can't take any 3s. I can't take any 5s. I can't take any 11s. When nothing is shared, the greatest common factor by default is a 1. And this is called relatively prime, or RP if you want to abbreviate it, relatively prime. Now let's take a look at LCM. Now remember, LCM, least common multiple, does not care whether the numbers are shared or not. It just cares about whether the numbers exist. Are there any 2s? Well, sure. Let's take the biggest 2. Are there any 3s? Yep. Let's take the biggest 3. Are there any 5s? Yep. Let's take the biggest 5. Are there any 11s? Well, let's take the biggest 11. The LCM is going to be the result of this multiplication. And again, I'm kind of cheating a little bit. I got a calculator next to me. You know, LCM always becomes quite big numbers. But the numbers are going to be a little bit easier to deal with, although this one wasn't too bad. It's basically 8 times 3 times 5 times 11. The lowest number that all of these guys can turn into with multiplication multiples is 2,640. The GCF is 1. The LCM is 2,640. Let's take a look at one last example. Oh my goodness, there's variables. What should we do? Well, we should not panic. I will show you what to do. The first thing we need to do in order to find GCF and LCM is we need to prime factorize all 3 of these numbers. 75 is divisible by a lot of things, 3 being one of them. 3 is prime. 25 is divisible by 5. Let's take a look at 150. 150 again is divisible by a lot of things. This time, let's do 3 again. 50 is divisible by 5. 10 is divisible by both 2 and 5. And then finally, let's take a look at 90. I'll do a 9 and 10 this time. 9 is not prime, we have to break it down. 10 is not prime, we have to break it down. All right, there we go. I have the numbers prime factorized. Now, let's make sure that we write them one on top of each other. The answer for this first one in black is 3 times 5 squared times x squared. Right? The x squared just kind of falls down to become part of our answer. The red one, we have a 2, so I'll put the 2 over here. This is like my 2 column right here. 2 times 3 times 5 squared times x to the 3rd. And finally, let's take a look at the green one. We have another 2. We have 3 squared. We have a 5. We have an x. And we also have a y squared. Notice I'm not drawing the columns like I did on the very first question, but I am keeping the column system. Again, let's focus on GCF first, the greatest common factor. GCF, we only want to look at the numbers that are shared. 2s are not shared. 3s are shared. All 3 of these have 3s. For GCF, let's take the smallest 3. 5s are shared. Again, for GCF, let's take the smallest 5. X's are shared as well. GCF takes the smallest x. Y's are not shared. The answer to the GCF is going to be 3 times 5 times x, which turns into 15x. The greatest common factor of these 3 numbers is 15x. So now let's look at LCM. We'll get rid of this work. LCM does not care whether the numbers are shared or not. They just want to know, does the number exist? We have 2s, and remember, LCM, it's kind of backwards. It says lowest or least, but we take the biggest 2. We have 3s, let's take the biggest 3. We have 5s, let's take the biggest 5. We have x's, let's take the biggest x. We have y's, let's take the biggest y. The LCM is going to be the result of 2 times 3 squared times 5 squared times x cubed times y squared. Now the numbers, we just have to do that math. I mean, that's going to be 2 times 9 times 25. That's going to be 450. The x and the y, they just kind of fall down. X cubed, y squared. The LCM of these 3 numbers is 450, x cubed, y squared. Again, to recap, to kind of go back into our notes. To recap, the greatest common factor, we prime factorize, we figure out what numbers are shared, and then we only take the smallest version of what is shared. For LCM, we prime factorize. We don't really care if they're shared or not. We just look for the numbers. Are there 2s, 3s, 5s? And we multiply the biggest. It is kind of funny. Greatest common factor tends to be pretty small numbers, like the answer. Least common multiple tends to be really big numbers. And that is how we find GCF and LCM. If you have any questions, please let me know. Hopefully these videos are helpful. I will see you later. Bye.